All right, parallelogram, we just did a little activity where we drew a parallelogram and measured sides and angles with rulers and protractors. So, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So if I were to mark that in my picture, remember that's with little arrows. So AB is parallel to DC, but also AD is parallel to BC. So when you mark with the arrows, that means that lines are parallel. Now, we measured with our rulers and found out these properties. So the first one, the opposite sides are congruent. So if I wanted to mark that in my picture, AB is equal to DC and AD is equal to BC. So the sides that are parallel are also congruent in length. So we can set those equal to each other. Then we went through and we measured some angles, and we found that this angle up here at A was equal to angle C, and angle D was equal to angle B. That's right. So opposite angles are also congruent. Then we realized that the ones that were on the same side, like the two angles at the bottom, C and D, were supplementary. So angle C and angle D, we could add those two up to equal 180. And that not only worked at the bottom, but it worked on the sides and the top. So we call those consecutive angles, or also same side angles. So those will add up to be 180. And then the last thing that we found out was about the diagonals. Were the diagonals equal? No, but they did bisect each other, which means the diagonals were split in half, right? Or the parts were equal. So DE was equal to EB, and AE was equal to EC. So a lot of things marked in that picture. Now you might want to make yourself an extra note here, because a lot of people get confused. What does that mean, diagonals bisect each other? And you can put the parts of a diagonal are equal. So the part, I guess, of each diagonal are equal to each other. So just like we marked DE is equal to EB, but that does not mean that DE is equal to AE. So the parts on the same diagonal are equal. So the diagonals are not equal, but the parts are equal on the same diagonal. Hoping that makes sense. Okay, the rest of the examples I have are on a worksheet for you, so I'm going to pass those out so that way you do not have to draw these parallelograms, but they will be drawn for you. But keep those properties out so that way you can refer to them. So let's look at our first example. We have PD. PD is equal to, well, here is PD. What is PD equal to? PE. And then the next one says CP is equal to, good. And it doesn't matter which way you write them. Does that mean that all four of those are equal to each other, though? No. Just diagonals bisect each other, so the parts of each diagonal are equal. All right, here's our next question. Is this a parallelogram? No, why not? Good. 114 does not equal 113. In a parallelogram, opposite angles, must be equal. So since 114 does not equal 113, those opposite angles are not equal to each other. All right, in our next problem, we are given HM is 2x plus 5. I'm one of these who likes to write things in a picture, so if you see the examples today, they're from the textbook or online, you might want to draw them out just so that way you can see them. So here we have HM is 2x plus 5. MJ is 4x minus 19. Well, what do you know about HM and MJ? They're equal. So over here to the side, let's set those two equal to each other and let's solve for x. What would you do to get x by itself? Subtract 2x on both sides. So 5 would equal 2x minus 19. Then, so 5 plus 19 is, and last step, divide by 2, x equals 12. Good. Don't forget that a lot of times in geometry, you want to be able to find multiple things. So up here it says find x, which we did, but it also says to find hj. How do I figure out what hj equals? Plug it in, plug it in. You're exactly right. So let's plug it back in over here. What is 2 times 12 plus 5? 29. And then we could also plug it in this one. 4 times 12 minus 19 is 29. And these should be equal, right? They should be the same because the parts of the diagonals are equal. But we want to know from H all the way to J. So what do we need to do? Add them together. What's 29 and 29? 58. So a great way to double check yourself is to actually go through and add those different pieces together and actually look at them. The next 3 examples have the same picture, but I decided I did not like the pictures. So I've made new pictures. So I'm really sorry about the handout that y'all have received that has the old picture, but this is what the new picture looks like. So you can get rid of those 3 pictures on your handout and draw the picture that is there at the top of the paper. I wanted to make the example to look a bit more like a parallelogram because I felt that those examples down there at the bottom didn't really embody the parallelogram kind of look. So this looks more like a parallelogram. Now, there are 3 questions here. So all 3 questions are different, but we're going to use the same picture. So I'm going to write on the picture and then erase, and then write on the picture and erase. If you want to draw the same picture 3 times, you can. That's completely up to you. But let's start with the first one here. It says, given PS is 5, so I'm going to put 5 right here, and PR is 20. Sorry. So this whole diagonal is 20. All right, so we want to find what is QR and PX. Well, what would be the distance of QR? It will be 5. Why is it 5? Opposite sides are congruent. And what is PX? PX would be 10 because the diagonals equal each other, the parts of them. They get bisected, so the diagonal gets cut in half. And that's it. So diagonals bisect, opposite sides are equal. All right, let's do our next one. The next one's talking about angles. Angle QPS is 125. If we were to trace out QPS, that's this whole angle here, is 125 degrees. Find angle QRS. Well, where is QRS? Is this bottom angle. So what's the measure of this angle? 125, because in a parallelogram, opposite angles are equal. Now let's find PQR. Well, PQR is the bottom left angle. How can we find it? Good. It should be supplementary to 125, so subtract it from 180 and we get 55. So remember, opposite angles are equal. The ones that are on the same side, also consecutive angles, are supplementary. All right, and the last one we have tells us angle 1 is 27 degrees. Angle 2 is 30 degrees. Now it says find angle 3. Now remember, in a parallelogram, we said opposite angles are congruent, right? So what is pretty much opposite from angle 3? Close, not angle 2, angle 1. So opposite is 1 and 2, but you need to keep going opposite. So angle 1 is equal to angle 3. So angle 1 is 27, so angle 3 is 27. Now, next it asks us for angle PSR. So PSR is this whole angle right here. What's this whole angle? 57. That's right. We would just add those two together. And the last thing this problem asks us for is angle QRS. QRS is this angle. Well, what do we know about this angle? It's supplementary to angle S, so we subtract it from 180. So what's 180 minus 57? 123. Very good. So keep that in mind that opposite angles are congruent. Any questions about these problems that we've done so far? So this is the majority of your homework, is just kind of going through and deciding what things are equal to each other. So you may set things equal. You may have to subtract from 180 if it's angles, and things like that. All right, flip over to the back. We are going to review some math too, because that's going to help us with the last thing that we need to do in parallelograms. So when you see lines that are parallel, it makes a lot of angles. There are 4 types of angles that we talked about in math 2. Can somebody name one? We did talk about vertical angles, but not with parallel lines. Okay. No, it does start with a C, but not congruent, but corresponding. Those are the 1 types of angles that we talked about. And corresponding angles are congruent. Now, let's label those first, and then I'll get y'all to figure out our next type. So, which ones are considered corresponding? Like angle 1 is corresponding to angle 5. Angle 1 and angle 5 are corresponding angles. They're on the same side of the transversal and they're congruent. So what's another pair? 2 and 6. What's another pair? And last? Good. So there are 4 sets of corresponding angles, and they are congruent. Okay. Corin, you had another type? Very good. Alternate interior angles. And those are also congruent. Now, think about what the words mean. Alternate is kind of like opposite. Interior means inside the parallel lines. Okay? So, which ones are considered alternate interior angles? 4 and 5 and? Good. Okay, we have 2 more types. Alternate exterior angles. And those are also congruent. So which ones are alternate exterior? 1 and 8. And the last, 2 and 7. There's one more type, and they are not congruent. They are supplementary. That's right. Same side interior, which are supplementary. Remember us repeating that a lot. Same side, supplementary. Same side, supplementary. So those will be adding up to 180. They're on the same side of the transversal. They're inside the parallel lines. So our 2 pairs are angle 3 plus angle 5 equals 180. And then also angles 4 plus 6 equals 180. And the last thing we're going to review from Math 2 is triangle congruence. So why is this triangle congruent to this triangle? Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. HL. Very good. So, like our first one says, 3 sides in one triangle have to be congruent to the corresponding 3 sides of the other. Side angle side is 2 sides in the included angle, so the angle between. Angle side angle, we have 2 angles and the side that connects the 2 angles. Angle angle side is 2 angles and a non-included side, so a side somewhere else. And then the last one is our angle side side, but we don't say angle side side, and we don't write down angle side side because we don't want to make an angle side side out of ourselves. So we say HL. So that's when we have a right triangle and we have a hypotenuse that's congruent and a leg that's congruent. Now, you may be wondering, why are we reviewing all this Math 2 stuff? Because if you notice, triangles will pop up in other things that we have, especially when we draw in diagonals, we see lots of triangles. And we're going to talk a lot more about triangles tomorrow. But it's also going to help us write something like this, which is called a proof. That's right. So we're going to do a proof together real quick. Now, don't forget, when you start your proof, always look at what? What's given? What's given? Wind is a parallelogram. Well, that's your first reason. We were given wind is a parallelogram, so we're going to write given in that spot. All right, the next thing that we have, well, actually, probably before we go to the next thing, we need to think about what is a parallelogram. So maybe there's a definition we could look back at. Look at your notebook paper. We wrote down a definition. What did the definition of a parallelogram say? That's right. It's a quadrilateral with both pairs of opposite sides parallel. What does that next sentence say? They're opposite sides, but it doesn't say equal. What's this symbol mean? Parallel. So guess what this one should be? That is correct. The root word there is parallel. So if we have a parallelogram, then we have parallel sides, and that's what the next one is telling us. Now the next part is showing us some angles. So anytime it gives you information, write it in your picture. So angle, I-N-Y, that's this small angle right here, is congruent to angle D-W-Y, which would be this one. Now, remember what it said. Here we're talking about parallel lines. Here we're talking about angles that are equal. In the previous slide, which it's not going to now, we had that list of parallel lines tells us what type of angles. So what type of angles are these based on those parallel lines? Perfect. Alternate interior angles. And that's all you need to write for that statement. Some people add are congruent, but I don't need that much. I just need to know what type of angles that they are. All right, our next statement says IN is congruent to WD. Well, here's IN and here's WD. We can say those are congruent because they're opposite sides, and opposite sides of a parallelogram are equal. Good. So that's what we say. Oh, now it decided to change. But we're just going to say opposite sides are congruent. Now, I know it's one of the properties, but you cannot write property 1 of parallelograms because we wrote it as property 1, but the next county over, it might have been property 2 or 3 for them. So you have to just say it in words. All right, 5 says angle IYN. Well, that's this angle right here. Now mark it with 2 marks because you've already marked one with 1. Is congruent to angle DYW. That's right. Those are vertical angles. And we know that vertical angles are congruent. We don't have to write are congruent. We just say vertical angles. Now, the next one is talking about what? The triangles. It's saying this triangle is congruent to this triangle. So we have to use one of these 5. So this is really important to mark the things above in your picture. So now if I look at this bottom picture, why is this triangle equal to this triangle? Angle, angle, side. We have 2 angles and the non-included side. You're exactly right. So our last one is also a review from Math 2. I'm not going to mark it in the picture, but this is those 5 letters. I know this was a long time ago. This is like February, March. But we said once our triangles are congruent, then we can say anything about those triangles are congruent because of C, P, C, T, C. That's right. Now we're going to write this down just one more time about what it means, but it basically says since the triangles are equal, then all their parts are equal, but it really says corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. That's what that means. If you don't remember the 5 letters, you can just say it in words. Since the triangles are congruent, their parts are congruent. I had another proof, but we don't have time for it, so I will show you guys that later. But we are just going to go ahead and work on our homework, which I'll pull up in just a second if my board decides to work again. But it is coming from the geometry book, which is the orange textbook back there, or you can look on Canvas to find the page. Don't forget we have a what tomorrow? Quiz. So all the stuff that we reviewed on whiteboards at the beginning of class about circumcenter, orthocenter, centroid, and the other one, incenter. Those are the ones that you need to know, and know the median, perpendicular bisector, altitude, and the other one that I keep forgetting about. Hey, tonight's homework too, you need to show your work when you're solving for variables. So if it says solve for X and Y, show that work. Okay? Any questions? Yes. All right.